Hi guys, this is a calculus video. This is to watch Monday night. Okay, so a bunch of them were to be watched, 3 of them were to be watched by Monday, but this is to be watched Monday night. And this is video 5-16. This is on U substitution and the fundamental theorem of calculus. The fundamental theorem of calculus is the theorem that connects antiderivatives to area under a curve, okay? It tells us that we can find the area under the curve without taking a limit and without using our calculator by finding the antiderivative and then plugging in the upper and lower limits and subtracting. Okay, that's what the fundamental theorem of calculus is. Okay, so here's a neat type of problem. We're going to solve for A. Okay, so A is some constant, and we're going to solve for it. We know that the integral from 3 to 9, okay, so if you have the upper and lower limits, if the integral sign is not empty, like I've been saying, it doesn't mean antiderivative. It means area under a curve, okay? So we have that the area under the curve from 3 to 9 of a times x squared dx equals 468. Now, guys, just something about notation. Some people might be like, well, what's the variable? Is a the variable or is x the variable? This is what tells you. Okay, so this dx at the end is telling you what the independent variable is. So it's x. Alrighty, so I'm just thinking of how I want to do this visually. All right, so we cannot get the a by itself. All right, so we're trying to solve for a. There's really no way of getting a by itself here. It's not like you can divide by everything else. But the fundamental theorem of calculus tells us that we can rewrite. Okay, so we know that the right side of the equation is 468. It's always going to be 468. And we would like to rewrite the left side of the equation. So actually, let me go like this. Let me bring down equals 468. And I want to rewrite the left side of the equation in a way so that I can solve for A, okay, like a regular algebraic equation. So I'm going to go off to the side, and I'm going to use the fundamental theorem of calculus to rewrite this. Okay, so the fundamental theorem of calculus tells us that this is equal to, okay, bracket 93, is equal to the antiderivative is what would go in here, and then we would evaluate it at 9 and then subtract what we get when we evaluate it at 3. So the antiderivative of this is what would go inside of there. And so I would add 1, so the new exponent would be 3, and then we would divide by 3. So this would be a over 3x to the third. And then the fundamental theorem of calculus says that this is equal to, I don't know what 9 to the third is. Crap. And I don't have a calculator. Okay, so just a second. So it's going to be 81 times 9. And then that's 729. Okay, so this is going to be, well, I'll go a little slower. So this is going to be a to the third times 9 to the third minus 8 to the, I'm at a over 3. 3 to the third. So this is equal to 729a over 3 minus 27a over 3. Okay? And then 81 times 3. Is that 243? I think that this is 243. 243, please comment below if I'm wrong. 243a minus 9a. And 243 minus 9 is 234. I don't even know. 234a, right? Minus 9, because minus 3 would be 240. And then minus another 6 would be 234. Okay, so the left side of this, so this integral actually, guys, by using the fundamental theorem of calculus, we got that this is equal to 234a. And then we just divide both sides by 234, and we get that A is equal to 468 divided by 234, which definitely simplifies because those are both even numbers, but I don't have a calculator on me, so I'm just going to stop there. I think you should simplify, though. Oh my gosh, is this just 2? 460, oh my gosh, I think that's just 2. Comment below if I'm wrong, please. Okay, guys, so there's that. Now, wait a minute, that doesn't seem right. Maybe it's right, I don't know. Something seems weird. Okay, never mind, we're just going to move on. All right, so this is example number 2. Yeah, and the first person to comment if I made a mistake would get a bonus point. Okay, example number 2, we're going to find this, okay? And we're going to find it without a calculator. If this was a calculator section of the AP test, don't even bother with the fundamental theorem. Just plug it into your calculator. It's going to save you so much precious time. But let's suppose we can't use our calculator here. So I need to find the antiderivative of this. Okay, I would need to go, equals, bracket, and then I would need the antiderivative to go inside of the bracket. But the problem is this. We do not know an antiderivative for the square root of 3x plus 1. We don't have it. We can't use power rule, and we don't know a formula. So you need to use U substitution. So I'm going to show you how this works when you have a definite integral or area under the curve with U substitution. So I'm going to let U equal, always choose a function within a function, okay, if you can see one. So I've got 3x plus 1 inside of the square root function. So 3x plus 1. Okay, so U equals that. So du is going to be equal to 3 dx. So dx is going to be 1/3 du. Okay, but here is the thing, guys. Since this integral is in terms of x, 1 and 5 represent x values. But we want to turn them into u values. All right, so I'm going to go back up here and I'm just going to say to myself, that's from x equals 1 to 5. Well, guys, when x equals 1, what is u? When x equals 5, what is u? So we're going to figure that out. So down here, I'm going to say, I'm going to go like this. I'm going to go x equals 1, then u equals, okay, so u is equal to this. So then u equals 3 times 1 plus 1, so u equals 4. All right, so the lower limit is going to turn to a 4. When x equals 5, then u equals 3 times 5 plus 1. So the upper limit is going to turn to 16. All right. So this in this method that I'm teaching you right now, it's going to avoid having to plug all the x's back in. We can just do this in terms of u completely. So this is equal to. So this is equal to. The integral, and make sure, guys, with these that you, I think it's important that you say x is equal to those, and now that we're changing it to u. So from u equals 4 to 16, okay, and now I'm just going to change the radical function to blank to the 1/2 because we're going to want to change it to that anyway, and then u goes inside there, and then I'm replacing the dx with 1/3 du. Okay, so this is equal to, I'll bring the 1/3 out front, and then this is the integral from u equals 4 to 16 of u to the 1/2 du. Okay, I'm going to work vertically here, so equals, I'll bring down the 1/3, bracket 16 u equals 4. Antiderivative of u to the 1/2 is u to the 3/2. It's going to be 2/3 u to the 3/2. And so this is equal to 1/3. Now, since I've got that 1/3 out front, guys, it's important that I have like brackets or something around like this stuff. So because it's 1/3 times the whole thing here. So 2/3. So this is going to be 2/3. And then 16 is going in for u, but the 1/2 exponent means I'm taking the square root. So that's going to be 4 to the third. 4 to the third. If that doesn't make sense, think about it. Minus 2/3. 4 gets plugged in there. But the 1/2 exponent means I'm taking the square root. So that's going to be 2 to the third. Alrighty. Now, I don't have my calculator on me, so I'm just gonna leave it, I guess. Equals, okay, and actually we'll go u finish. Okay, so you finish that. Okay, friends, we've got one more. It is this one. Okay, find this without a calculator. Okay, so, I'm finding the area under the curve of this function here. So the integral, from 0 to pi of that function there. It's a sum of other functions. So it's a sum, guys, and this one is just x to the first, so I can easily just use power rule there. Plus sine of 1/3 x. Now, we know the antiderivative of sine of x, but we don't know the antiderivative of sine of 1/3 of x. And remember, if you can't use power rule and you don't know a formula to get the antiderivative, you've got to try u substitution. So I'm going to split it up like this, kind of like what I did on the last video. So the integral from 0 to pi of x dx plus, I'm going to need u substitution here. Okay. So the integral from 0 to pi of sine of 1/3 of x dx. All right, and if you want, since we're going to be using u substitution, I think that's a good presentation if you're clear to your reader that those are x values. But then again, this dx at the end kind of should imply that, but okay. I wouldn't take off if you didn't do that. Alrighty, so this one's not going to be too bad. All right, but this one here we're going to need u substitution for. So I'm going to hold off on that one. And then this one I will let u equal, always look for an inside function. So I see 1/3 x that is inside of sine of x. So u equals that. Actually, let me move over here. So u equals 1/3 x. So the differential du is 1/3 dx. So dx is 3 du. Okay, but then since this is a definite integral, we've also got to change the limits of integration. So when x equals 0, so if x equals 0, then u equals 0, because we're just plugging x, or 0 in there. So the lower limit is going to, with u's, is going to be 0. And then when x equals pi, u will be pi over 3. Okay, because I just plugged pi into there. All right, so that's what my upper and lower limits are going to be on the second one. Okay, so this is equal to the integral, I don't know, I won't put x equals, plus the integral, but if you change the limits, you definitely should tell your reader. Now these are u's. From u equals 0, whoopsie, you couldn't see what I did there. I just brought that down. From u equals 0 to pi, and then this is going to be sine of u times 3 du. And it's not a bad idea to just bring that 3 out front. So I'll just go like that. Okay, now I'm going to use the fundamental theorem of calculus on these. So I'm going to have, okay, so brackets pi 0. This is going to be 1/2 x to the second. Bring down that plus sign, bring down the 3. Brackets. The antiderivative of sine of u is negative cosine of u. I messed up. That should be pi over 3. That should be pi over 3. My bad. Okay. And then, so pi goes in here. So this is 1/2 pi squared minus 1/2 0 squared. Okay, that's what this first thing becomes. Plus 3, and then this is negative cosine pi over 3 minus negative cosine, so plus cosine of 0. Okay, now I don't have my calculator on me, so I'm going to have to think a little bit. So go ahead of me if you've got this, guys. This is, okay, so this is just 1/2 pi squared plus 3. Okay, so let me think. So, all right, so I got 30, 60, 90, 2, okay, so cosine of pi over 3 is 1/2. So that's negative 1/2, and please comment if I make a mistake. Plus cosine of 0 is 1. So this is negative 1/2 pi squared plus 3 times 1/2. This is equal to, that'll be 3 halves and 1/2. So this will be pi squared plus 3 over 2. Okay, guys, there is just a teensy bit of homework with this. This is page 26, number 8 is the homework, and it's very similar to example 1. Alrighty, guys, I will see you tomorrow. Bye-bye.